today we are going to discuss about the macro placement. Okay, this is very important, guys. I'm again telling it's very important in our physical design flow. So if you make the good floor plan, your life will be easy. Okay, again I'm telling you, the floor plan actually decide your partition QR, whether the QR is good or not. So you should understand the macro placement first. How do you place the macros, and why do you place them like that only? Okay, I'll go through very in detail. If you have any doubts, please interrupt me and I'll explain that. Okay, let's see. So there are some basic guidelines we should follow first. Okay, the basic guidelines. First is fly lines. Fly lines. I explained right in the last class. Fly lines are the virtual connections which tell us what is the data data flow between the macro to macro, or IO ports to the macro, like that. Okay, this is the virtual connections only, which tell us the data flow. Interviewer may ask you also this, what is the fly line? Okay, you need to tell fly lines are the virtual connections which help us to understand the data flow of the design. You can tell like that also. Okay, then port communication. Ports communication. Okay, let's say, so this is your partition. So macro guidelines are very important, guys. You need to minimum, you need to drag these topics in the interview minimum 5 minutes minimum. Okay, at least to drag the interview. Okay, this is a very important topic. So okay, let's see fly lines. Let's say you have the macros like this. Okay, year one macro. Macros are always will be like this only, right? The square box, the big square box. Okay, so the macros will have the pins like this. Every macro will have the pins like this. So the fly lines will, if you select these pins in the tool, so it will tell like this. Okay, the pin connections like this. It will how it is communicating with the macros. Okay, this is macro to macro communication. I also told macro to IO ports, right? Let's say there is one IO ports here. Okay, this is the IO port. So it also tell how the macro is communicating with the IO ports, like this. Macro will have n number of ports. There is no limitation, like it should have certain ports. Macro can have any number of ports. It maybe some macros will have 300 pins, we call this pins, sorry, 300 pins or 400 pins, like that, any number of pins. So some pins may be communicating with the IO ports. So these are the IO ports, input and output ports. Okay, so this is this communication we will get to know by the fly lines, because fly lines will not have the physical connection. It is just a virtual connection. We just see it, that's it. It will not have the physical connection. Physical connections like the router, the route stage, it will route like this, the like what metal layer. Let's say this like this. It is M1 and this is M2. So this is the real physical connection. This is just virtual connection. So if you want to understand the communication between between two macros or IOs, you can't wait till the route, right? So in the floor plan itself, you should understand how the macros are communicating with others. That's why they give us some virtual connections to understand our data flow, how the data flow is in our design. Okay, that is the fly line. So this is the port communication, how the macros are macros are communicating with the ports. Okay, these are macro guidelines I should mention here. Guidelines, because interviewer will ask you what are the macro guidelines, then you should start telling these points. Okay, ports connection, and the macros are placed at boundaries. Macros should be placed at the boundaries. This is very, very important. Let's say, uh, okay, so this is your partition. So what I'm saying here, the macro should be placed at the boundaries. Boundary means the this one, right? This line, the line I draw just now. It is the boundary for our design. Okay. So what this point saying, macro should be placed at the boundaries. Let's say you have maybe 5 macros. Let's say 5 macros. Okay, any number of macros you can have. It depends on the design and the full chip guy, how you partition, how he does, or he or she does the full chip partition, right? Based on them only you will get this macro count. Let's say, for example, we have the 5 macros. One macro is very tall like this. This is okay. Let me take different color. So this is very tall macro, very big and very tall. Okay, and maybe you have one more macro like this. Okay, and one macro is very small like this. Okay, 3, and one macro maybe it occupying the full height. Okay, and another is maybe, let's say, like this. You are placing the macros like this. Okay, these are the 5 macros you place like this. So this point saying like macro should be placed at the boundaries. So these every time make sure you should not place the macros at the middle of the core area. This is the middle of the core area. Okay, make sure you should not place the macros in the middle of the core area, because macros will have the certain blockages. Okay, it will not allow the routing. So the router will get interrupted because of this macros. Then it will need to like detour like this the routing to communicate with some standard cells. That is the reason the general guideline is like macros should not be placed in the middle of the core area. The macros always should be placed at the boundary of the our design. Because I told you that macro is like it's like hard macro. We also call HM hard macro, or also we can call SRAMs. If you name it as SRAM is also nothing but a macro only. Macro, hard macro or SRAM. I told you that macro like it's let's say you have the A plus B equal to C equation, which already implemented with this macro. So you want to use this functionality in multiple places in your design. Then what they will do, the foundry guys say, hey, I have this functionality already implemented. If you want, you can use it. We also call as a IP, maybe IPs also. But general term, we in our the real time world, we just call macros or SRAMs. Okay, so they tell like we have this functionality IP, so you can reuse. So this also this functionality, it will be implemented same like this only. Like someone else will implement this, and they will give it to us, and we just plug and play. We just use it. That's it. So they will also will have the IO ports, right, in there. Like if someone else did this, and they will also when they were doing, they will also have the IO ports, and they will have the standard cells inside. They will do all the routing, and they will make sure the clock tree built nicely, and everything they will do, and they will give us like this, and we just use it. That's why. So that's why we will have some routing blockages inside the macro. Means maybe they use from M0 to M5. Let's say we have M14 layers. Okay, let's say M0 to M14. In this macro, they used M0 to M5 layers already, so you cannot use These M0, M5 layers are used to implement this functionality. Okay. Then what you need to do, you need to use from over this macro, you need to use from M6. Okay, M6 to M14. That layers only you should use. That's why that is the main reason we should not place the macros inside in middle of the core area. Okay, because if you place the middle of the core area, let's say one signal needs to routed on M1 only, let's say, okay, M1, but what happened, you placed here, okay, you placed here, but that M1 is already blocked. The macro already used that M1 layer, or else the track, we also call it the track already used by this SRAM, the macro, then the router cannot route it, then it need to detour, like it need to go up and again go straight and down and go like this. If any cell sitting here and then in any other cell sitting here and these two cells are communicating, then it needs to go like this way. So to avoid this kind of problems, we should place the macros at the boundaries. Okay, then and macros should be grouped based on the logical hierarchy. Okay, this is also one of the important point. Okay, macros should be grouped based on the logical hierarchy. Okay, so what does it mean is, let's say this is your partition. What this point is, macro should be grouped based on the logical hierarchy. Okay, logical hierarchy means you have the macros. Let's say you have around, let's say 5 macros like this. Okay, very small macro and very horizontal macro, and maybe very square macro like this. So in the tool, you will have the feature that, like a view hierarchy feature. So I'll tell you in our lab session. So you need to enable that. Okay. Yeah, once you enable that feature, so it will color the based on the hierarchy, like what hierarchy needs to be grouped. It will color it actually. I have some slides, I will show you that later. But for theoretically, just understand, macros should be grouped based on the logical hierarchy. That will happen in the tool. Okay, tool we will have we will have the option like view hierarchy. If you click on that, it will color the macros based on the same logical hierarchy. Let's say these 1, 2, 3. These 3 macros are within the same hierarchy. Let's say maybe the macro name is let's say this is A, and okay, maybe let's say 1, right? Okay, this is a top hierarchy. Let's say A is the one of the top hierarchy A, and then what in the, like in the netlist they will define A underscore 1 1 like this, and A underscore 2 like this, and 3 like this. So that means it is one hierarchy. So it is clearly telling these 3 macros should be grouped at one place. Maybe you can place like this. Okay, here, and one more macro here. Maybe you need to place one macro here. So these 3 should be grouped. Okay, let's say this is B hierarchy. Okay, then it will be the, maybe this is 4 and 5, then B/4 and 5. Okay, this will be by default, the tool will get identified. Okay, you don't need to do anything. The tool will read the netlist, and it will identify like which macros are need to be grouped. It will color it. Okay, we will do it in the lab sessions. Okay, let's say this is need to be grouped, then you will place maybe somewhere here based on the fly line connectivity. Okay, you will check the pins connection, how it is communicating, then you will place, and maybe one macro here. Okay, like this you will place. So this is grouped, and this is one more group. Okay. Yeah. So the next is spacing between the macros. You should give the spacing between the macros. So this is very, very important spacing also. Let's say you have a partition like this, and you place the macros. Okay, you place the macros like this. Okay, let's say you have again 5 macros. Maybe you need to place, you may be placed like this, and maybe you aborted this macros. You didn't give any space between these two macros. Okay, you aborted. Okay, maybe one more, let's say you place like this. Okay, the 5 macros you placed 1, 2, 3, 4, and 5. So what you did here, you did not give any spacing here, right? You just aborted it. Abort. Okay, note this terminology. Okay, abort. Abort means like no spacing. Okay, you need to say like this. Okay, I aborted my macros. Okay, you note down this terminology. We use this regularly in our daily life. Okay, aborted. Okay, let's say this is we call as a abort. You didn't give any spacing between them. What will happen? So I told you, right, macros will have the pins. Let's say the pins are like this. Okay, like this. The pins, let's say M4. The pins are on M4. I told you, right, macro might have used M0 to M4 layers, and then the output will be on M4. Then output will communicate with our local logic, right? So it is on M4. Then what you did, you aborted them. You aborted it. Let's say you have one more, this macro have few more pins here. Okay, macro 4 have few more pins, and macro 1 have few more pins. Then you did aborted. Okay, same like here, 2 and 3, then and 4 and 5 also. Then what tool understand, like tool will not get the routing resources here, right? The tracks you are fully used, you don't have the tracks here, you didn't give any space between them. Okay, let's say this macro, one macro is communicating with some port here. Okay, some port here, this is some IO port here, it is communicating like this. You did not give, maybe the port is sitting here, and all the way it needs to communicate here, and maybe from this the very far end port to here. Okay, this till here, the depth here, maybe let's say 100 microns the distance. Okay, I told you in the class, we will measure the distance in the microns. Okay, let's say this is the 100 microns. The pin itself cannot drive the 100 microns. You need to buffer it. Means you need to add the buffers in between, which help you boost the signal, and also like reduce the RC, the delays, right? So the buffer, it will boost the signal. So you need to add in between the buffers, each 50 microns, let's say. Okay, this is an example. Let's say this, for each 50 microns, you need to add one buffer. If you don't add one buffer, you will see the tran violations. Okay, the tran violation. I told you, right, in the beginning or in some middle of the class, the cell delay depends on the input tran and output load. Okay, this is the cap. Okay, input tran and output load, the cell delay depends on. If you, the pin itself cannot drive the 100 microns. Okay, so what you will see, the tran will be very bad, then your cell delay will become very bad. Okay, cell delay also will become very bad. That's why you should get good tran. Okay, what you are doing here, because of no space, you didn't give any space between them, then the macro pin itself need to drive the 100 microns. Then you will see the lot of delays. That is the reason you should make some space between the each macros for the optimization. We also call optimization is nothing but you make sure then the signal or the net, this is the signal we also call signal, should be optimized, means it should get better tran and cap value, so that you will get the better delays, and the path will meet in the timing wise. Okay, that is the reason you should give the space between the each macro. So this is very important point, the spacing between the macros. Okay. We know we should give the spacing between the macros. Then how and like what? How do we give this spacing between the macros? There is a formula. Okay, let me write that formula. Distance or space. Let's say space between macros is equal to number of pins. Okay, number of pins. What pins? The macro pins. Okay, I explained here, right? The macro pins, how many number of pins you have here. Let's say one macro having 2 pins and 4 macros are having 2 pins, total 4 pins. Okay, number of pins into pitch by available layers. Okay, this is okay by available layers. So let's say we have let's say our number of pins 4 right?
Yeah, 4.
Okay, so pitch, I told you, can anyone guess where we get this pitch value?
In left.
Very good, in the left. I think somewhere here I explain. Yeah, see, in the left, in the tech left. Okay, left, like in the left we will get the pitch value. So there will be some commands to get the pitch value. We will see in practically how do we see this pitch value. Either you can, if you want to know, even if you can open the left file and see the pitch value. Okay, so let's say the pitch value is maybe 0.2 microns, let's say, just an example. Okay, and by maybe 14. Okay, so this will give the 0.0571 microns. Okay, microns So this is the distance you need to give the each macro to macro. Okay, the between two macros you should give the this much distance. This is a rough example, but it will not be like this much. We will generally, like in real time, we will give minimum 1 microns. Okay, minimum we will give 1 micron, or else some people give 5 microns is more actually. 1 is good enough, I think. So yeah, you need to give that much space between the two macros. Okay, and yeah, then next. So you understood, right? This one. So okay, let's say one more thing. Okay, you can ask me like, okay, I have 5 macros here. It's easy for me to calculate. Let's say I have 300 macros. Okay, 300 macros in one design. Obviously it is very difficult, right? Like you can't seriously you can't go and calculate the space between the macros. It is like it doesn't make sense that for 300 microns. Then what they will do, like they will do some trial and error runs. Okay, they will give some 0.5 microns and they will launch the run and they will see the congestion. And if the congestion is bad at the macro area, then they will give the more channel space. We also can call channel also nothing but the space. So interviewer will ask you what is the channel of your macros. then you should give you should tell 1 micron or 2 microns. That's it. Okay. Yeah, for 300 microns, roughly, like maybe you will launch some trial and error runs, and you will decide which let's say you started with 0.5 microns, which given you the bad results. Then what you will do, you will increase the space between the macros, that 1 micron. Then you will launch the run, you will check the congestion. Okay, now your congestion is good. Then you decide, okay, one micron is good enough for my design. That's how we generally check. Okay. Okay. So okay, this next point is you should avoid the notches. Okay, avoid the notches. Means, okay, avoid the notches means, okay, let me draw. This is your floor plan or design. So you have very tall macro, and you have one more tall macro you placed here, and you have very small macro you placed here. So this area is the notch. Okay, this area is the notch. Okay, this area mostly you should try to avoid this, because like some routing purpose only, like it will obviously it will like the router needs to go the like this way, the horizontal, again it will go down like this way, and again it will go like and go like this and go like this. So to avoid this zigzag routing, so better you bring this, okay, bring this macro to here. Okay, then you don't have the notch here, so it is like very evenly you align, right? This one you align very evenly. Okay, the macro here, the small macro here, right? Maybe you can bring here like this. Okay, so you can do like that. So he, at least here you avoided the notch. Here it is okay, I mean you can't do anything, you have this kind of macros, so it is still okay to place the macros like this, because you have no other option. But if you place this macro like this, then it is an issue. Then someone will come and ask you, why don't you bring this macro to here? Okay, still if you want to place here, then you should have a reason for it. Maybe the reasons will be like the macro these two, I mean these two macros are same hierarchy, and this is different hierarchy, so I want to place like this, because the same hierarchy, these two same hierarchy, right? These two macros, the logic will come and sit here. Okay, the logic will come and sit here, and easy for the router to communicate with this logic to these two macros. And this macro is the different hierarchy, and the logic will come and sit here, maybe somewhere here, somewhere. Okay, the logic come and sit around this macro. So this is okay, you if you have the proper justification, yeah, people will understand. But if you no reason, you simply place here, right? They will look at you way, like, yeah. So that's why you should have a proper reason if you are placing the macro placement. If you are if these two macros are the same group, okay, you abort them. And if the pins are not here, let's say if you don't have the pins here, the macro pins are here. Okay, and these macro pins are here, it is facing this side, you can still abort here. Okay, note this point. If the pins are like this, the pins are not blocked, then you can still abort. Okay, you can still abort, because you don't have any pins, you can still abort here. Okay, then yeah, if let's say if these three macros are same group, then better you bring this macro here, and the small macro you bring after this macro. Okay, that is the notch. So you should try to avoid the notches. And the orientation also very important. Orientation is nothing but like we will have the R180, R90, based on the technology node you are using, and the based on the foundry you are using. Like the left lips foundry, generally they will give, right? So based on the foundry also, your orientations will be changed. R270 and MX. So generally we see like this. The naming will be like this. So some like 90 degrees and 270 degrees and 180 degrees. So you can flip the macro like this. You can also flip the macro. So this is the macro, right? You can flip like this. You can place it horizontal also. It is even though it is when you get the macro, it's vertical, but you can flip it. Let's say okay, let me draw this. Okay, let's say this is your macro. Okay, initially they have given you like maybe R90, okay, 90 degrees. Okay, let's say, just assume. So this is to align this macro with your existing macros. Maybe, okay, let me draw again here. This is your floor plan design, and you have the macros like this. Okay, one is like this. Okay, maybe R90. Maybe one is like this. Let's say maybe R180. Just assume, okay. Maybe, yeah, I think your pins are like this. Let's say your pins are like this and like this. Okay, you want to place this macro. So it is maybe, okay, you place like this. This is R90. So you will also have the feasibility of rotate this macro. That is the orientation. Okay, if you, let's say you also place this macro somewhere here like this, maybe like this. Okay. So what you will do, you can rotate this macro like this in the tool. Okay, you can rotate like this. Maybe you can, if you have IO ports here, let's say IO ports here, and this macro is communicating. Initially they have given you this R180, but you can change the orientation like this, which help to communicate with this IO ports easily, right? So this will become 180. So this is no more R80. I'm just telling one example. Okay, this will become R9 90 degrees. Okay, so you will have this feasibility in the tool. Then then it will help to router to communicate this like this directly. So initially what you have done, you place this macro vertically, right? Sorry, horizontally. Okay, let me do one thing. So yeah, so like this you placed initially. What tool does, it has to route all the way like this. Okay, this is very difficult to the tool. You are wasting the resources also, like horizontal resources and vertical resources, and again you are going for horizontal, again going for vertical resources. You are wasting the lot of resources. Instead of doing this, you can do like you can change the orientation, and you can help the tool to do like this, so it will communicate directly. So that is the importance of the orientation. So that if any interviewer asks you, you can also tell we can flip the macro. Okay, you can flip the macro, but you should make sure you should not um, like the port should not like, if let's say this is the two macros, right? The pins, the pins should not merge together. Okay, I mean the you should not abort pin side macro. Okay, you should make sure while you are you are changing the orientation of the macros. And also some orientations will not be allowed in some particular foundries. Let's say to a TSMC, maybe they allow only R180 and R90 degrees. They don't allow MX and 270. So you should not use this orientation. If you use, it will lead some base violations, and your chip will be bursted. It will not work. So that's why you should also know before you start the macro placement, what are the legal orientations for your design. Okay, legal orientation. Okay, legal orientation also you should understand. You should know, you should ask your lead or someone, what are the legal orientations for this technology node. Then they will tell you R180, R90 are the legal. You can go ahead and use them. So you can flip the macros based on it. And blockages, you need to apply the blockages. Maybe this is hard blockages. Okay, later I will tell you the blockages, what kind of blockages we have, and when should we use the blockages. Let's say this is your partition. It's a like very let's say, okay, this is your partition, very weird shape you have, like this. Okay, maybe yeah, like this. This is your partition. Okay, so here this is very narrow channel. Okay, this is very narrow channel. If you place any cells here, if you place any cells here, right, they will not get proper power supply. If they don't get proper power supply, then it will go into the metastable state, and sometimes the cell will not function as expected. Okay, so that's why what we will do, we will apply some route hard placement blockage. Okay, this area, this complete, this is the hard placement blockage, which means no cells will be allowed to sit in this area. It is nothing but like you should feel like you don't have this area. But you can ask me then, okay, why they are giving like this. Maybe let's say you have the full chip like this. Maybe let's say your one, maybe they have some macro here. Maybe this some IP, some maybe PLL. Let's say PLL. Okay, PLL is sitting inside the full chip. This is your full chip. I told you, right? PLL. I think in the STA class I told to some batch 2, batch 1. I think. Let's say this is full chip. I'll later explain PLL. PLL is nothing but like which produce the clock actually. Okay. Phase local loop. I think in your academics also you might study. I'll explain this later in our STA classes. Let's say this is a PLL. PLL sitting here. This is like it must sit here only. They don't have other option to move this PLL here and there in their core area, in the full chip core area. So what they will do, maybe your partition, some partition is like this. They did partitioning like this. Okay, some partition, maybe this is block A, and maybe let's say maybe our partition like this. Let me draw our partition first. It will maybe here and here. Okay, let's say, so this is our partition block, block B, and some maybe other partitions are like this. Okay, okay, this is different partition C, and this partition is D. Okay, so yeah, so some reason, some based on say, some logic, I explained, right, how on what basis they do the partitioning, right? So based on some critical logic, some clocking, maybe some because of this PLL is sitting here, they have to do the partitioning like this, and they'll give the partition shape like this. So in this case, you can't avoid this narrow channel. Okay, this narrow channel. Okay, this is our partition. So this narrow channel, you will still get it. So what do you need to do? So you should block it to avoid further issues. So it's still fine. You have to block it because if you use this area, right, you will see a lot of issues in the IR drop and the power related issues you will get. That's the reason. And also you don't have the much tracks here to route these standard cells. Standard cells will have the pins, right? That pins needs to get routed, right? So the pins definitely will communicate somewhere, maybe here, maybe some cell is sitting here. So this has to be routed, but you don't have the enough routing resources in this channel. To avoid all these problems, better you block it. That better you place the hard placement blockage. Hard placement, okay? Hard placement blockage. This is the hard placement blockage. So this is the point which says you should also add the hot placement or some blockages wherever you need it in the floor plan itself. Floor plan, what we will do? We will do the macro placement based on these all macro guidelines and also the pin placement and the power planning. We will do these things in the floor plan itself. Okay. And the next, avoid the crisscross placement of macros. Okay. Avoid the crisscross placement of macros. Okay. What does it mean? Okay. Let me. Okay. This is your partition. Okay. You placed your macro here. Okay. And your your pins are here, let's say. Okay. And this is, let's say this is R90 degrees, let's say. And some cases, okay, let me, your orientation is maybe here. Okay. This is, let's say, R270 orientation. And your pins are here. Let's say this is 1, 2, 3, 4, and 5 pins. Okay. And here 1, 2, 3, 4, and 5 pins. Okay. So crisscross means actually one will talk with the one pin. Okay. The one signal, let's say signal, let's call signal. Okay. One signal is communicate with the, okay, this is macro A and macro B. So macro A, one signal will communicate with the macro B, one signal, and 2 with this, and 3 this, 4 this, and 5 this. Okay, let's say. So this is a crisscross connection. Okay, again I'm repeating, this is a crisscross. Okay, crisscross. This is the crisscross connection. So this is like for router also it is very difficult, right? A router generally it will route in a vertical or horizontal. If you give like this, and it's very difficult. Maybe it will go horizontal and like this and route like this. Again, it needs to go like this. If you have enough spacing, then you will find the enough tracks. Let's say you don't have the enough space, then you will route on top of here and here, yeah, like this. Then yeah, it needs to route like this. Then you will see lot of shorts and congestion, everything. This is very worst placement. So that's why you should avoid the crisscross connection. Then what you will do, you will flip this macro, you will flip it. Maybe I think not like this. Maybe if you flip it right, the macro pins will come this side and the connection will be very straight. I cannot draw properly, but the general thing, like you need to flip the macro, then the connections will go like this. Okay, like this. It's a straight connection. Then for router, it is very easy, right? Just it will both are on let's M4. Then it will draw one M4 metal here. That's it. It's very simple to the router, and your life is become very easy. No shorts, no congestion, nothing. Okay. And this is the avoid the crisscross connection. And the next, maybe you should Let me think. Yeah, I think you should better place the macros. Uh, um, Place the macros at no pin side, no ports. Let's say no ports side. Okay, what does it mean is, uh, okay, this is your partition. You have the ports here. Okay, maybe here, here, and here. Ports can be anywhere based on your full chip. Let's say I just drawn here, right? Your shape is here. You will have the ports here and also here, because you communicate with the block C and block A, and also D also. Okay, like this. Let's say you have the ports here and this side also. Okay, okay. Let's say this is the pin side or port side area. Okay, this area, and this area is non-pin side area. Okay, this full area and this area. So always you should better prefer to place the macros non-pin side area, like this here. Okay, like this. Okay, better you place the macros here, not here, because if you place the here, right, then you are blocking the routing of these ports. You are blocking the routing of these ports. Let's say, okay, I told you somewhere here, okay, we should place like near the ports, right? Let's say these ports all are communicating with these macros is okay. You can do like this, but if it is not communicating, all the this macro is not communicating with these ports completely, then better you better you place this macro near these ports and like this. Okay, near the near the port mean like this, you can place here, so that router will come and route like this. Still fine. Instead of you block this area, better you place the macro here. Okay, so that is what, like you like place the macros at no port side. Okay, I think, or else non-pin side also we can say. I think I covered most of the points then. So anyone of you have any doubts?
So exactly what is the macro and what is the partition depends main. So actually we will place in chip partitions are block, right? So what is the difference between that macros and partitions?
Okay, I explained it. Okay, let me explain one more time. So okay, this is your macro. Okay, one second. Give me 1 second. Okay, sorry guys, I got one call. Okay, so yeah, the macro. Let's say this is your macro. The macro is like it will have the static functionality. Static means let's say you have the spec adder. Let's say this is adder. Okay, this is adder functionality. Adder means which adds the inputs, and it will give the some value, right? Adder. Let's say let just assume. Okay, so in your this is your partition. Okay, this is your partition. This adder functionality being used number of times in your partition. You have the netlist.v, right? .v, maybe maybe, okay, let's say you have the spec called you want to improve the camera, like maybe camera feature. Okay, camera feature. To improve the camera feature, you need to use lot of adders. Okay. Okay. So this adder will, let's say, include some cells. Okay. Maybe this is AND gate. Maybe it needs to go one more AND gate for adder. Let's assume. Okay. So these are the two cells. Maybe if you 100 times if you are using this adder in your design, means 200 cells. For these 200 cells, you need to route and you need to make sure the timing meet and no congestion, and you need to do everything. And this will increase the complexity of the design. Maybe this camera feature having a lot of function, and adder is one of the function among those functionalities. Okay, let's say. So this will increasing the complexity, right? So what they will do, the foundry guy, okay, the foundry guy say, we will give this netlist to them, and I mean, we will tell our feature to foundry guy. This is my feature I'm going to release, and this is my netlist, and this is the netlist having this some ABCD logic. In that we are using this adder logic in this. So what the foundry guy say? Hey, I have the adder logic already implemented. Okay, this 200 cells. Okay, this logic already implemented in this macro form. Generally, this is macro is like a hard macro. Our partition also we call it soft macro. Okay, we also call this as a soft macro. Means this is your like you are changing the functionality however you want, right? Let's say tomorrow you want to add the subtract, maybe the divider. Let's say in this camera feature divider you want to add it, then you can add it, right? But this hard macro you can't, right? This is a fixed logic. You can't do anything. If this fixed logic being used in your netlist, you can use this macro. So this 200 cells, 100, like maybe this 200 cells become one macro. So you will use it as one. Okay, this act as a adder, and you can use any number of places, same macro. Okay, any number of places. That's the reason, like to make the to make the complexity easy. So we will use the macros. Macros are like it's already implemented. You don't implement this. Maybe let's say someone implemented. Okay, you need to implement this. Okay, this is a block, the soft macro A. You need to implement based on this spec. In this spec, you are using this adder functionality, so you don't need to implement this again in your partition. So you just simply use plug and play. You just take the IP from the foundry guys. Means you will take the .lib and .left. Okay, .lib and .left, and you will get this macro in your design, and you use it and you get it done. That's it.
A black and we should design, right? Based
Yes,
on
yes,
these macros, so we should design block,
yes, yes.
partition block.
This one you should design. You should design. And this macros, you don't need to worry about it. Macros you will be given by default if your design having. Okay, but the thing you need to know, macros are nothing but like it's a hard macro. It is some fixed logic. It will have some fixed logic. Like you don't know what logic it is. I'm just giving example adder here, but in the real time, in the real world, you don't know. You don't know even what logic it is. No one will tell you. Even you don't need to know it. If they give, you just simply use it and make sure the macro, let's say if this is the macro, this macro timing should meet inside your partition. That's it. That is the only thing you should make sure. And you just simply use it. That's it. You don't need to do any analysis for this macro. Because this is a hard macro and the fixed logic, and this macro already timing is met and congestion is good and everything is good. They implemented everything nicely and they will give it to you. You just take it and use it, and also this macros will have the pins, right? The pins will communicate
Yeah.
to your logic, your local logic. Okay, you should make sure
Okay.
that timing is meet. Okay, that's the thing only. You should do it. That's it.
Local logic means blocks or partition pins, right? So we should communicate with this
Yeah, local logic
pins
means
only,
okay.
right?
You are using that macro here. This is your macro.
Yeah.
This is your partition A. Local logic. This is the adder. We just told like this is the adder, right? So
Yeah.
maybe
Okay.
you need to use subtractor, which the foundry
Okay.
guys they don't have that a macro. Then what you will do? Maybe the subtractor logic will sit here, okay, and it is communicating like this. Then you need to meet the timing for this. If they have this logic also, then you will be given as a macro like this. Okay, this is this macro. Then if these two macros will communicate, then what you will do? You will do the macro placement based on this guidelines. Right? Just now we discussed the guidelines. So you use that
Yeah.
guideline and you will place these macros, and yeah, you will avoid the crisscross, and you will make sure the channel is proper. Yeah, all these guidelines you will use it.
Yeah, we'll follow and we'll design on macro, right, newly. So based on that design, if is then requirement, we will also like that is a hard macro you told me. Like this is if you require any macro, we can design or we will get it from foundry team only.
You will get it from the foundry guys. The in the form of dot lips and dot left. Dot lips will have the
Yeah,
timing timing information of this macro. Okay, and dot left will
Okay.
have the width and height, the macro size, the footprint. Okay, again I'm repeating footprint. The footprint of
Yeah.
this macros it will have, and you just use those two
Mm.
files. If you use those two files, you
Mm.
will get this shape. That's it. And the timing
Okay,
information and
automatic.
everything will be available there.
So, okay, this is the chip we will do it or in this partition only we will work on it, right? These macros in place in uh,
Come
uh,
again. Sorry, come again.
no, no. These macros we'll place it in chip partition. Right? The partition will get it. We'll work on block or partition. So while working in place it in blocks only, right? These macros or in place it in chip. These
Okay.
macros.
Okay. Let's say this is your full chip. Okay. Let's say this
Okay.
is your
Yeah.
full chip. Full chip guy will
Okay.
have the macros also. Okay. Let's say he
Okay.
will have the macros like this. Okay. He will be given the macros like this, maybe like this. And what that guy will do? That guy will do the partitioning, right? So
Yes.
let's say he might have done the partition like this. Okay. So when he has done the partitioning, these three macros will come to A guy, and these three will come to the B guy, and this one macro come to the C guy. So this is how the full chip guy partition, and he will give these lefts and lips to you. These macros, lefts and lips, and the netlist, the logic, everything. The full chip guy will give you. I mean everything in the sense what is the shape and what is the logic you have, and these things the full chip guy will give you. But the actual lips and lefts, the overall lips and lefts, you will get from the foundry guys.
Okay.
Okay.
Yeah.
Yeah.
So from that we will follow the guidelines and we'll place it
Yes.
in our partition, right? These
Yeah.
macros. Okay.
Yeah. Yes. You need to follow all these guidelines and you need to place the macros.
Place the macros in given partition.
Yes,
A or B or
you
C,
need to
whichever partition.
load your partition. This partition, let's say A is your partition. You need to load your
Yeah.
shell and place the. Who is talking now? Music.
Yes.
Can
Yes.
you please go on? Oh, you are the one. No, sorry. Someone is talking background. Sorry. Yeah. Okay. So, yeah. So this is how you need to do. You will get the macros by default. The moment you open the floor plan, you will see the macros, and you need to place the macros using these guidelines. So don't worry, I'll explain you again in the lab session how we place the macros, and what again you need to check, how you check the fly lengths, and how you give the channel, the space between the macros, and how you check the logical hierarchy, and the other we will place the macros at the boundaries, and we will also try, let's place the macros, block the IO ports, and run the flow. We'll see what impacts. Okay, and if you don't avoid the notches, however QR, and we'll see the orientation. Okay, and the blockages also will apply. And yeah, we will see, we will make some crisscross connection, and let's see how the routing been done, and what is the difference between the non crisscross connections and the crisscross connection placement. Okay, yeah, we will discuss more in very detailed in the lab session.
Okay, thank you. Thank you.
Okay, anyone have any doubts still? So guys, I think you should by heart these points again. Okay, the macro guidelines are very, very important. Even if you get the 10 years of experience, right? These questions will be asked by the interviewer, even if you get the 10 years experience, because these are very important. If you're not doing the floor plan properly, then it leads lot of issues that we discussed in our last class, like the macro placement also decide the timing congestion, right? So that's what. So if you don't make a good floor plan, then your life become hell. So that's why interviewer, definitely it's a must question actually. So minimum you should talk about minimum 5 minutes minimum. If you drag for 10 minutes also fine, because you have many things to explain to the interviewer here, like okay, fly line. Okay, you need to tell what is the fly line, why do you need it, and the ports communication, and the macro should be placed at the boundaries. Why should we place at the boundaries? You should talk about that before the interviewer asks you, so that you can counter attack the interviewer. Like he will not ask you some difficult questions. Then you will understand. Okay, you know better. You should give very deep knowledge to the interviewer, because interviewer will not brush up these points, right? These points, because he might have started very early in his career. He will not remember all these points. If you start telling these points, right, then he will be impressed. Then also it is a recap to him. Then he will also understand, like maybe he might forget some points, and if you highlight them, you will get good impression. And you can also tell the spacing between the macros, and how do you calculate the spacing between the macros, and the notches. Why do you avoid the notches? The reasons. The router will like it will be difficult for the router to route the signals. Yeah, even I'll say the document. You can go through that document. It will explain very clearly. Okay, I given the basic knowledge for them to get start. Okay. Okay. So this is clear to everyone, right?
Yes, sir.
Yes.
Okay. So this one we covered, macro placement, the floor plan checks. You can go through it, and yeah, this one, right? Just now we discussed. This is the crisscross connections. So see, this is the one macro. This is one macro, and this is this one. They become like this, very straight connection. So it is easy for the router. And see this one also. This one also become like this, right? This one. So a good floor plan can make implementation process cakewalk, of course. So if you make the good floor plan, then your placement of standard cells will be very optimized placement, and CTS, your clock tree will very good, and the router job will become very easy. And then timing closure become very easy. And similarly, a bad floor plan can create all kind of issues in the design, the congestion issues, timing issues, noise, and IR drop. And we discussed it, like the notch. If you don't avoid, if you don't place the placement blockade, you will see the IR violation, the routing issues. And the bad floor plan will blow up the area. Means like if you does the bad floor planning, the optimization, like the tool try to add many buffers. Okay, let's say if you, this is your partition and these are the IO ports, and you're supposed to place your macro here. So then it will add one buffer and drive it, add one buffer, drive it, add one buffer, drive it. But you, what you did, you place this macro here. Then what tool do? It needs to come like this. Then it will add lot of buffers. Instead of 3 buffers, then 9 buffers you need to add to drive these 3 signals. Okay. Then your area will blow up. The power, of course, the number of cells increased, the power will get increased, and it affects the reliability, life of the IC, and also it can increase the overall IC cost. Maybe the silicon space, it may increase, and more effort to closure, and more LVTs and ULVTs for timing. And before start of floor plan, it is better to have basic design understanding. So design understanding, I told you, right, the fly line connectivity, the data flow, you should understand, like how the macros, you see here, how the macros are communicating. The macro is communicating with this macro. So here they placed beside each other. That's what. Before start of floor plan, it is better to have the basic design understanding and data flow. See, data flow of the design and integration guidelines of any special analog hard IPs in the design. We also call these are IPs. Okay, intellectual properties, I think. So some let's say PLL in your block, then you need to take some special care for the PLL. Like you should not route over the PLL. Okay, like that. Some that kind of special caring will give, the instructions will be given by the full chip guy. So you should take care of them in the floor plan itself while doing the macro placement. Okay, and the block and partition are same. Okay, again I'm repeating, block and partition are same. The block and partition level designs understanding the placement and IO interactions of the block in full chip will help in designing good floor plan. Okay, so I think this is the last slide. Yeah, I think hopefully this is clear to everyone. I'll give a pause here. I think it's already 10. Sorry, I think it is I think we are half an hour more. I think let's stop here, and I will pause for some time for any questions. Right? Okay. If you have any doubts, please ask me.
Hello?
Yes.
Shravan,
Yes, we do.
why we place these macros in middle? We can't place macros in middle. Can you explain?
Yeah. So, okay. So this is your partition. Okay. What I told, macros will have the some level of routing blockages. I mean, it will use, right? Let's say adder is the one macro. Let's say to implement this adder will also have the logic, right? Let's say this is the logic. Okay. This is the macro. Inside you have this logic. So to route and for routing purpose, it will use some methods. Let's say M0 to M5. Let's say, okay. This is the small macro, right? Maybe it used M0 to M5, and this is your partition. You will also have the layers called M0 to M14, let's say. So in between the macro, if you place here, this adder macro, if you place here, it is already blocked M0 to M5. Let's say this is your blocked area. Okay. And maybe you have given one IO port, okay, which is on M4, let's say. It is sitting here. And this is your, let's say this is your maybe this is input port, this is output port, let's say. So this is also M4. So what happened here? The M4 is already blocked here, right? I told you M0 to M5 it is used already. So M4 is blocked. The router, it's supposed to go like this. If it is not blocked M4, it's supposed to go like this. But what happened here? You blocked, you place the SRAM here, the macro here, and you blocked it. And what it does? The tool route till here with M4. And it will detour, okay, detour, okay. You remember the word detour, okay, DETOUR, okay, detour. Okay, what happened? M4 it is routing, and it will go to M5. Instead of a straight line M4, it is detouring to M5. Again, it will go to M4. Here no blockage, right? M4. Again, it will come down M5 and M4. So you are seeing the issue here, right? So let's say this is 100 microns. The straight line is 100 micron distance. Because of this detour, it will increase by again one more 100. Then it will become 200 microns. Then 200 microns routing means obviously the delay will increase, and the buffers the buffers count will increase. Instead of maybe if you add here 2 buffers, and it will you may need to add 4 buffers to drive this 200 microns. So like it is causing lot of issues. The buffer count is increasing. Okay, the buffer count is increasing. The net RC, okay, resistance and capacitance delay. The cell delays mean the buffer delays, and the RC's delays are increasing. Then your timing may not meet, just because you place the macro in the middle of the core area. That's the reason you never place the macros in the middle of the core area. You should either edge of the boundary edge of the your partition you should place. Okay, is it clear?
Yes.
I have a small question. You told that if let's say take an example of that red square you drawn.
Which one?
Any example?
I did not understand the question. Can you please repeat?
Yes, actually, if I place one micro in edge area near to
Okay.
suppose I have that IO cells, I have 4 pins, 10 pins, then 5 pins connected to IOs and 5 others. So if my maximum pin is connected to IO, then it is good to place that in edge area. I mean outer surface, like
Right,
near
right,
to
right.
IO.
Right.
But what if half of pins connected to IOs and half to other places? So how
Okay,
to connect?
that's what, right? I told you, right? We can flip the macro. Okay, you can flip it like this. Okay, then it is easy, right? Maybe okay. Let's say you have some standard cells. The macro is communicating with some kind of standard cells here. Okay, then it may going like this also. Okay, and it will go like this. So instead of you place this macro, if you okay, so if you place this right, sorry, so okay, so if you place this right, place this like this, and if you have the standard cells here, it needs to route like this, right? All the way it need to go back and route. So it will cause the problem. And but it also communicate with the ports. Okay.
Yes.
Then in this case, what you will do, you will flip the macro. That is the flip feature we have in our design, like the PD flow. So you can flip it. Then router, it's easy, right? It just route like this, and it will just go like this.
Right. Suppose we have 10 pins, 3 pins connected to IOs and 7 pins outer. So it's good to draw like this.
Yeah. So the main motive, like the main intention of the macro placement is like you should avoid the obstructions. Like the just now we discussed, right? It is obstructing to communicate. The macro pins are obstructing to communicate with the standard cells. So it is more about your engineering judgments. Okay, how good you place the macro. It may be okay. I maybe the one who doesn't know macro placement, that guy will place here. Okay, it is still fine, but the thing is, the RC delays, the cell delays are increasing. That will make the timing difficult to converge. Okay, that's what like you should understand very well about the macro guidelines and where should place and where should not place and how the data flow communication is happening. Here you told me like the macro is communicating with the IO ports and also some logic in my design. So what I did, I flipped the macro. Then it is easy for router to route these signals. So it is depends on how you think. Okay, maybe some guys maybe like who knows very well about the floor planning and who knows the macro guidelines, they may place the very better than me actually. So even you still accept that because he's the placement of his macro placement is like reducing the the RC delays and the cell delays, then it's good, right? It will, your design quality QR is good. Everyone will accept that kind of designs. So it's purely your technique and yeah, your engineering judgment.
Okay, that's
And,
completely depend on
the-
that situation.
Yeah, the
scenario.
more design knowledge you have, right, it will, the macro placement will become very easy. Okay.
Okay.
Right now, even the project I'm doing right now, I'm also doing the macro placement. I did many trial runs and yeah, still my macro placement is not good. So I'm still almost I run the floor plan almost 50 times. Okay, just imagine. So macro interviewer definitely will ask you your macro, like how many iterations do you complete your macro placement in one iteration? He will ask you. You should say no. I cannot complete my macro placement in one iteration. I will take minimum more like minimum 10 plus or 20 plus iterations to understand the congestion and timing issues. You should say like that. That is also one of the interview question. If you say yeah one right, then you are gone. Like he will understand. He will know like okay, you know, you don't know about macro placement. So in the real time, no one can finish the macro placement at once. So some people does 100 times also the macro placement, because he will place this macro here and here and here. He will move the macro here and there and check the congestion and timing how it is. And the place which he gets the good QR means the congestion and timing results, he will fix that placement for that particular macro.
Okay, thank you.
Yeah. Okay, guys. I think if you don't have any question, then let's disperse. And hopefully, I'm planning to start the lab sessions in our next class, so that we can discuss so far whatever we discussed, and also you will understand easily, and you will remember these concepts easily if you if you do practically. Theoretically, I'll explain any number of hours, but it's not the our main motive is like you should learn something, right? So I'll teach you the tool till the floor plan. Like I'll show you the inputs, and I'll maybe we don't need to run the flow actually, because ours is the test related, right? Like just to explore the design. So there will be a design which is fully routed, and but still I'll try my best to explain in a better way. And yeah, we will, let's see together. Even I don't know what kind of inputs we have there. I will also see with you guys, and let's explore together. And I'll teach you multiple macro placements, and I may ask you to generate some different kinds of macro placement, and the results, and the reasons also. Why do you place, and why don't you place like this? So yeah, going forward we will go like this, okay? And I will conduct some basic interview questions on these till now what we covered till macro, right? I'll think of it. I'll whether this is the right time to conduct or not. And if not, then I'll proceed. I'll try to explain. Actually, I have one more slide. I think this one. This actually clearly tells. It is actually, it impacts more, and it gives you more knowledge. So maybe I'll cover these 65 slides, and maybe then you get a good idea. I think. I'll see how I'll proceed next. And but very soon I will start the lab. Once we finish the floor plan, right, we should start the lab, and I will ask you to do a number of trials. See, I think you see a number of macros, and we will discuss in the next class, and what is the options we have, and how do we select, see here the color the macros, right? So we will discuss in the next class as this. Maybe I'll talk about these slides first, then we'll go for the labs. Okay. And after the class finish, after I discussed everything, all these slides, right, then I'll share this document with you, the PPT with you. Then you can go through it. Then only you will understand better. If I simply throw this in our shared directory, then if you go through, then you may not understand, and you will get you will not get interest. So if you read some points, right, if you should know, oh, I read, I heard this terminology, and I think I'm very relevant to this. Then you will start reading it, right? So that's why I don't give this document to you now. Okay, I'll go through this first, then I'll give you. Okay, guys. I think it's too late. Let's disperse them. Thank you, guys. Bye.
Thank you.